students, welcome back to my class. In the series of learning programming in C, in the previous video we have discussed about structures and pointers. And in today's video we will discuss about structures and functions. Structures and functions with call by value method we have discussed in the last session. That is call by value method. But now we will see structures and function with call by reference. Reference means address. So when we have to deal with address, so we should know about pointers, and that we have done in the previous video. So please do check out the playlist. Understand what is structures and pointers first, and then come to this video to understand how to pass structures as argument to function with call by reference method. So we will see the execution of this program also. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. And watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Here we go with the program to understand structure and function, which is call by reference method. Reference means address. So here structure and function. To the function I am passing the structure but not the copy of the structure but the address of the structure. So how I can send the address? That is with the ampersand operator. We send the structure address, base address, and we receive that through pointers. Well, how the pointer is going to act on structure variable, we have understood in the previous video. Please do check out the playlist before you understand this. Okay, structure and pointers has to be cleared first, and then we can understand the structure and function called by reference method. So understand structure and pointers first. Okay, now let me have the structure, the same structure, struct student, character array, name and age. So these two are the members. Okay, so structure definition is done. We have the function declaration. The function name is print, return type is void, and I am taking the structure itself as argument, but it is structure pointer. So I just say struct student asterisk yes. Semicolon, so it is declaration. Here comes the definition part of print function. So we have void print struct student asterisk yes. We'll come back to this later on. Let us start from the main function. So what it is going to do, what this structure pointer is going to get, we'll see now. In the main function, what we do? We have struct student std. So we are creating structure variable, normal structure variable, and we are initializing it also with the values. So as soon as the compiler encounters this, like as I said, structure variable is like internal pointer. So the structure variable std is going to get some memory. Say it is 4000. It is an internal pointer to point to the base address of the structure. So the base address is 1000. So it is pointing to this location. So here base address is 1000. So this base address will be held in this structure variable std. So std will be pointing to this location 1000. Okay, and we have initialized the values. Then what I do? I call the print function. And in this print function, I am passing an argument. And here I am not passing the copy of the structure. I am not just saying ampersand. I am not just saying std, I am saying ampersand of std. If it was just std, then means I am sending the copy of the structure. Then when a copy of the structure is sent, I need to receive that with new structure that we have seen in structure and function with call by value method. But this is call by reference. Reference means address. I need to send the address, that is ampersand operator. I need to send the address of std. So what is std? It is 4000. And what do we have in this 4000? It is internal pointer. It is pointing to the base address. So now I say ampersand of std. I am invoking this function. So function is getting invoked print function is called now, and for that print function I am passing the address of STD, means I am sending the address of STD, that is 4000. This address, so when a function is invoked, control will be to the definition part. In the definition part, I am receiving that in the function definition header, I am receiving that with a structure pointer, that is yes. So this yes, which is a structure pointer, receives this address. Pointer is getting the address. So it is pointing to 4000 and it is redirecting to the base address. What do we have in 4000? It is the base address of the structure. So we are pointing to the structure members. So ampersand of STD is sent, received with this structure pointer. This is yes. Now yes is receiving the address. So it is pointing to this STD. And what do we have in STD? It is the base address. This is what the base address means address of the first member of the structure. Okay. Now it is pointing to 1000. So means I am pointing to the same structure. So then what I'll do? I'll say print the name. Name equal to percentage yes. Then here when I am using structure pointer, I need to use arrow mark. So I am redirecting yes. Yes is 4000. What do we have in 4000? It is 1000. 1000 dot, that is arrow mark, not dot. We are using pointer. 1000 arrow mark name. So I am referring to this. So in the output, I am going to get yes. Okay. Then I say age. So name, it is yes. New line. Then I say age. It is percentage D. Yes is pointing to 4000. 4000 is pointing to 1000. I say yes dot S arrow mark name, because structure pointer, not dot, arrow mark. So yes arrow mark name is done. Yes arrow mark age. So what is the value there? It is 35. Right. So through this structure pointer, I am pointing to the same structure. Pointer is receiving address, means I am pointing to the same location. Then what I'll do? I'll say yes arrow mark age. Yes means this, arrow mark age, I say 45. So yes is pointing to the structure variable, and this structure variable is an internal pointer. It is pointing to the base address. I say yes arrow mark age. I am changing this value. So whatever changes I am doing here in the function definition will be reflected back to the same structure, because I am pointing to the same structure. So I say yes arrow mark age equal to 45. A change is done in the function definition. So this function is done. I'll be back to the main program. So in the main program, what I'll do, I can just print the value of STD. So here it is normal variable, so I have to use dot operator. I say printf. Now it is printf. I say new age percentage D, new age percentage D. Then what I should say? STD. This is STD, right? STD dot. Here STD is normal variable, so I have to use dot. STD dot age. Here's the bracket. So here what happens? STD means it is 1000 itself. STD is 4000. The address of STD is 4000. What do we have in this? It is 1000. I say STD dot age. What I should get? I should get the new age, which is 45. So I get the message new age 45. So whatever changes I did in the structure definition, it was reflected back, because I performed the operation, all the operations was done to the same structure itself. That is what we say when we pass the structure to function with call by reference method. The changes that what we do in the function definition will be reflected back to the place where the function was called. So here I'll come back, then I'll say std.age, it is not 35, it is 45. So let us see how this changed value can be printed with the complete program and execution. So here we go with the complete program on structures and functions with call by reference method. So the structure that what we have defined is the struct student character name and int age. So we have the structure passed to the function. So here we have the function declaration, which is print function. And for that, just observe we are passing pointer. This is declaration. And in the definition part, so we have this definition part here. So the definition part, we have the structure passed as argument to the function print, and we are printing through that structure pointer yes arrow mark name, yes arrow mark age. So in the main function we have std, the structure variable, then we accept the age and name through the normal structure variable, then here we call the function. So inside the function call, so we are passing the address of std. So here when I call the function here, the control will be to this definition part. So in the definition part here I am sending the address. So here I am sending the address of std, right? So when I am sending the address, I am receiving that through pointer. And when I am receiving that through pointer, sorry, this one, definition part, through pointer, so we are pointing to the same location. So I am trying to access that yes.name and yes.age. Then I am trying to do the changes in the same structure. So yes arrow mark age 45. So after the completion of this function, I'll come back to the main function. Then I'll print new age. So new age I should get 45. So here it is pointing to the same structure. So I'm doing the changes to the same structure. So changes in the function definition is reflected back to the place where the function was called. And now if I try to print the new age, it is std.age. Here it is normal variable. So std.age means it is 45. So let us save this program and run the program. So I should get the message to enter the name, enter the age. So let me enter the name. I say Yashoda. Then I say age 35. Press enter. See Yashoda 35. And here I have changed the age. So it is 45. So my new age it is 45. So this is what the changes that what I do in the function definition is getting reflected back because I am passing the same structure. Whatever changes I am doing to the same structure itself. That's all for today's video. So in the next video, till then, take care. Bye bye.